Hello everybody, so welcome to the 5th episode of Learning Golang for Absolute Beginners. Today we're going to be looking at packages and arrays. Packages are basically ways of organizing large portions of code so that it can be reused by lots of other projects that you make. Some code you write will be very specific to the current project, but some code may be useful for lots of projects. A function like askInt, which we've written in the last lesson, or maybe the lesson before. Anyway, askInt could be quite useful to lots of projects throughout this tutorial. I'm expecting it to be something that we use. So I'm going to put that in a package along with a couple of other related functions so that we can call on them whenever we need them. Arrays are basically lists, and in Golang terminology, an array is fixed size. So you can have a list of 20 things or a list of 10 things. And as you move it around, it's all 10 things. But they also have something called a slice in Golang, which is the resizable version of arrays. Some languages do this slightly differently. So we're going to be using slices to keep our lists in, but a slice is, I guess, for now we'll just say that's a kind of array. It's a resizable version of array. There's more to them than that, but basically that's all we need to know. So anyway, on to the lesson. How did you do with last week's challenge? If I remember correctly, I asked us to use a random number in guess anyway for our program. So instead of going exactly halfway, we're going to use a random number between that range, which basically means we need to come up with a random number between that range. So our range, currently we're going halfway between lowest and highest, but actually we just want a number that's between lowest and highest. So how do we get that? Well, obviously, I think I told you, you're going to need to use ran.intn. And our range is obviously our highest number minus the lowest number. And our lowest number, but this will only give us a number from 0 to highest minus lowest. We need to make sure it's at least the lowest, so we're going to add lowest. And I'm pretty sure that covers what we want to do for the challenge. So let's give that a go. Go run lesson3.go. So that's, say yes when you think of a number between 1 and 10. 100. Let's say 34. Is it 24, higher or lower? So it's chosen a random number. I'm going to say higher, because obviously we said 34. Is it 37? Lower. Is it 34? Yes. So you got quite lucky there. But if we run it again, the thing we never did do, and I probably should do, is we should seed it so it comes up with a different result every time. But for now, I'm just going to test it with a different number. I'm going to test it with 100. It's good to test the boundaries of these things. So the number is between 1 and 100. So if we have one. Yes, is it 24? It's higher. It's going to say 37 again. Yes, it's higher than 37 because it's 100 this time. So we should get a different number, higher. 87, higher. 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 Aha! We got a problem. I think it's thrown an error because the range was negative, right? Is that what it said? It threw an error if we tried to give it a negative random number. And highest at 100, highest minus 1. Lowest is 1. Let's go have a quick peek at the docs just to make sure I understand. I'm pretty sure I know what that is. So it's rand inten. That should probably get us the Golang one. I don't think other languages call it that. I don't want a function example. I wanted the library. There's the library. Find inten. Function. Control ntn. Here it returns. It panics if n is less than or equal to 0. That makes sense. I was thinking that we somehow got lower than 0, but it's actually complaining if we give it 0. That's a surprise. I would expect you just to get 0 in that case. Because of course what we've done is we've got our number, the answer should be 100 at this point. So if the point where it reaches equal, I'm tempted to make a wrapper function because it feels like a pain to do, to go. Oh no, we could just do it here. I think for our purposes it's only short term. If highest equals if highest is less than or equal to lowest, mid equals lowest. Oh, else now I'm pretty sure we have mid has been defined somewhere else. Must. No, there's our colon equals on mid. So there, aha! Better way of solving this. Mid colon equals lowest. That way we've set mid, so we've assigned it to an int, and then in this, if highest is greater than lowest, then we can set it to the random value, and that should save us if we get to a point where it's a shitty point. Oh, got an error. It's syntax errors thrown up in expected declaration found in ident 109 column 2. Okay, I think I know what's gone wrong here. There it is. X. Fix that. So what had happened there is that because I closed the squiggly brace there, it couldn't work out where it was supposed to be. Oops. Undefined hires. Did I write something? Oh, that's supposed to be highest. Here we go. Mid declared and not used. Oh. So this is a fun thing about scope with variables. We've got this variable called mid here, and I put a colon equals here, which was declaring a brand new variable, and not using this variable that I thought I was using. So the colon equals here is creating a new one. And inside this scope, if I created a new one called mid, then as long as I was inside this scope, I'd only be referring to that. But that scope is only between these two squiggly braces here. So I didn't want to declare a new one. I want to use the one that we already have here. and that's this. That should fix that problem. Say yes when you think of a number. Yes. Shall we go for 100 again? Higher, 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 higher. We say higher again. Let's see what we get. Don't be a cheaty cheetos. 101. Yes, lower or higher. So we'll say yes. We've been a cheaty cheater. There was another part of this introduction that I wanted to do. I kind of set this as an aside, print to end. So we'll. This was in the comments underneath the video. So now we're going to take two ints, and we're going to take a bottom base int, top int. So there's two ints we're taking in now, and we're going to change this now. We don't need this here. We can do for I colon equals base I plus plus. This is I is less than or equal to top semicolon I plus plus. That was our exit condition, so we don't need that. We don't need that here. This actually does our printing of all of the numbers from base to top in a single run. So if I just throw that in at the top of our main function, print to n, I think I called it, didn't I? And that takes two numbers, so I can throw that any numbers. I can say 34 to 67 and run it. And we have 67 included and 34 at the bottom. So that was all we needed to do for that second part of the challenge. On to today's actual lesson, where we shift the package around, the bit I was supposed to be getting to really quickly. And the challenge is to move this into a package. We're going to put some of this. So I'm going to create a new directory. Now, there are two ways of doing this on most computer systems. You can do it in the command line, or you can do it with the folder view. I'm going to create the first folder with the folder view to show you. I'm sure you know how to create folders by now. Forget that. I'm just going to do that here. cd ... So I'm in the source directory here, and I'm going to make a new directory. I could do this way. So where's my programming scripts? Go source, same directory. So if I go create new folder and call it my lib. Laptop battery critically low. Give it power. So I've created that mylib folder. Again, in the command line, it's exactly the same. We've now got mylib, cd mylib, and I'm going to do make directory. And this time I'm going to call it, we'll call it Asker. I think that's a good name for this package. So now we have this package. It's in mylib Asker, and now we're inside Asker. We'll do that here. Now I'm going to do that. I'm going to stay here and use this one. No, back here. Tab edit .. mylib Asker. So .. is going up a directory from where I currently am working. Mylib Asker, and I'm going to make a new file here, and we're going to call this asker.go. So we've just created a new text file inside that folder. I did it slightly convoluted to show you how it's done, but normally I'd have probably just done a couple of make dars and then stuck it in. So if you look at the folder tree again, scripts, go, this is all the same. Inside the source, I now have a directory called mylib, and now I've made a new directory called Asker. And in here, when I hit Control W, empty file, but it's there, see? The file is right there. And that's all I've done, just created a new file, and this is where our package is going to be. So if I call it undo that, package name. Okay. No, this isn't package main. This is Asker. Package is called Asker. That's how this is going to work. So when we refer to it outside of our normal code, and the next thing I'm going to do is I'm going to move some of the functions across. This function called askInt is coming out of... Oh, and we'll take out askhigher lower too. Though that feels oddly specific to this program, so I might leave it in here. So we'll delete, copy that, and now I'm going to put that here. Oh, and because this is now in a package, we need it to be public, and Golang has a funny thing, which is actually quite handy. I didn't realize how powerful this was going to be. But basically what it does, by making it capital, is you instantly know whether these are public variables or not. So you don't need to go and check the declaration. So I'm going to make that a capital A instead of a small a. So now our function can now be called. So if I save this, Control W, it's not complaining anymore. So our package now has this method called askInt. And this side doesn't have a method called askInt. In fact, it's got this. It does refer to askInt, doesn't it? We've got a couple of places. Only the one place. Okay. So we're going to change that to a capital, because we changed the name of the function in the thing. We now need to change the name of this. So go back here to cd. I'm going to do this go, run, lesson 3 dot, okay. And it says undefined function askInt. Well, because we've taken the function out. But that's because this function now exists in another place. It exists in a place called mylib Asker. So in theory, this should now work. Aha! Of course that's the case. It's complaining now that buff.io doesn't exist in the library. So one of the things we need in Asker, it's using buff.io and standard in and thumped. Oh, and string convert. Yeah, that's using all of them. So I'm going to just quickly copy all of these across and get rid of the ones I don't need. So copy, put that over the top, paste those all in. So now we've got the imports. Now I think the ones we don't need, we're not using rand anymore. Buff.io, we're definitely using thumped. Obviously we're not going to import ourselves. So and now, aha! So these two complaints are related. Go 7. So in the main package on line 7, we import mylib.asker, which the plan is to use it, but we're not using it yet. And then it's saying there's a function called askInt that's been defined. AskInt doesn't make any sense. But to refer to a package's function, we now need to call. We now have to get asker.askInt, and that should do the job. Doesn't even use it. It's still on the old function. But there we go. We don't need that println anymore. We'll go back to seeker. We'll do it seeker followed by keeper. And now when we run the program, say yes when you think of a number between 1 and 100. Yes. Is it 24? No. Oh, higher. So it's using the function correctly, But now it's not in the same file, it's in a completely separate package, and that's all it is to packages, really. The package's paths are always given relative to go path, which is that environment variable we set. Whew, that was funny. So I've just ended the input and it doesn't know what to do with that. That's funny. That should probably panic and leave. I'll consider adding that at some point. I was expecting to be able to talk to the user, and I came across an end of file. So yeah, that's all it is. If you remember, we defined an environment variable called goPath, and that's what the value is. So home Matthew scripts go. So that's where I've defined it to for this computer, and that's inside that there is the source folder where all of our source code is, and that's how. So it's relative to the source actually. It will find the packages. And if you download packages from somewhere like GitHub, which will come up later, they will go into your Go package source github.com / and then the package name, and you can just access them with github.com / package name. It's really, really tidy. So that's one of the things. I'm not the only person who really likes this about Go. When I discovered this was how it worked, I got quite excited. Can't say for certain that I didn't run around the house and go, look Tasha, it does imports so nicely. Anyway, my wife, she puts up with an awful lot from me. Let's carry on. What are we doing now? Lesson 5. Arrays. Yes. Let's create a new function in here that uses arrays. So back over here, we're now going to have our ask set function, the one that I wanted to write last week, but I hadn't mentioned arrays and it was going to take too long. Ask array. Oh, ask set. Ask set. So now this is going to have a message just like before. But the next thing it's going to take is a slice, and to define a slice you give it a name first, of course. Set. And that is a slice of string, and this will return a string. That's pretty tidy. And we'll need some pretty similar stuff to before. Scanner :equals. So what we're going to do is we're going to receive a list of words. That's what the set will be. So an example set will look something like, I'll just comment it so we don't. Will look something like this. Oh. Higher, lower, yes. But this could be used for other programs too, and this may mean we can get rid of our other function from the previous program by using an array like this, and saving ourselves a whole bunch of work. So scanner equals buffio dot new scanner, and that's taking os dot standard in. I'm just copying above, just like I did last time. For funct.printf, and then we're going to print out the message with a new line and those two things to say I want you to say something, and then the message will be placed into that bracket. S : scanner dot text, bracket. And this time we're not trying to do a conversion, so we don't need to use that. Now what we're going to do is we're going to ask if that is on that list. Now I have a feeling that there is a function in Golang called contain. So if you've got a slice, you can ask if it contains something like. I'm not going to use that right now because I want to show you how a common way of looping through arrays. And it uses a for loop just like we've already done. I'm going to make it as a separate function. We don't have to. Oh, this should be a capital A because we want it to be public, don't we? So that should be with all capital A. I'm going to make a new func here, and this one doesn't necessarily need to be public because we're just going to use it locally. Contains, and it's going to take string. No, it's going to take a string with a name, and then it's going to take a set. Again, S and set are just the names, and let's take a slice of strings. And in here, we're going to make our own for loop. For and remember how we did the for loop where you get the power to make a couple of things. So you first initialize it. I equals colon equals 0. I is less than len. I think it's len. It'll complain if this is wrong. I think there is a function called len. It's not even a library function. I think it's a core language part which will return the length of an array or some other things. And then we need our incrementer, I++. So I will then, so the first time this runs, I will be 0, and it will take the 0th part of that list. So if you've got a list like higher, lower, and yes, the first one is 0, list at 0. The second one is list at 1, and the third one is list at 2. And the length of this list is 1, 2, 3. So when this loop begins, it starts I will be 0, and then it will do everything in this. What's inside here, and then, well, the first thing we'll do is I is 0. Is that less than the length? Yes, it is. So it will do the loop, and then it will add 1 to I and go, is that less than the length? And then it will carry on. So I will be 1. So we can access all of the parts of the array in this loop. And we go if set at I. This is how we reference parts of an array. You can actually just put a number in here, of course. Variables just take their place. So I could put set at 3, and this would of course return the third element of the array, which, if we send it this array, will be 1, 0, 1, 2, 3. It will be undefined, and it will complain, and it will throw a big error, which is why we make sure we work inside the arrays. And if that is equal to S, then we've found our thing. We can return true. Ha! I forgot to say what return type this function has. It's Boolean. Boolean just means true or false, so it's either yes or no. There's only 2 possible answers to a Boolean question. Did you have lunch today? Yes? No? You can't say sort of. False. Otherwise, so at any point, if it finds it, it returns true. But if it goes through the entire list and doesn't find that string, it returns false. So now we can ask the question, if contains, and our string is S from the scanner, This is a different S to this S up here. They just happen to be going to the same place. And set. Yeah, we'll just pass it set. Then we return S. That's a success. Otherwise, we return funct.printf s error colon s percent s, because we're going to put in a fancy string, is not an acceptable answer. Should probably give that quotes as well. And give it a new line, comma, and that will be S, because that's what they typed. Close that bracket. So I think this ought to work now, except that we've not got anyone calling it. So now, instead of ask yes, higher, lower, I think we can get rid of this entire function all together, because I think the only place we call it, we call it in two places, but here we don't want higher, lower, we only want yes. And so we're going to ask set here, asker.ask set, and yet we have a message, say yes, and our set that we're requiring will just be the word in an array. Oh, I think we need to say what it is. I think that's the way you say it. So this is how you make a new byte slice. So we're making a new byte slice of strings, and these are its contents. So new byte slice of string, and these are the contents. The ask higher lower has also been removed here, so we'll need to change this one. To asker.ask set, and again we need to give it a set. I'll find out in a second if this is not the right way of doing it, but it feels like it's pretty close. And the answers available are yes, higher, and lower. Oh, and there was another thing, because of course last time it returned a 0, 1. Something's missing. Okay, that took me a little while to find. I knew it could be did, and my mistake was just using the wrong kind of braces, actually. So let's find the place where we've got it. What I was supposed to write here was, as before, and then string, but this time I need to have those as those kind of brackets. and then that should not complain, except that I also have them somewhere further down. Okay, so no complaints, and it runs. So it took me a little while to research and just to make sure I had that right. But so this says this is an array of string, and these are the contents I am putting into it. So yes, higher, and lower. So now if we run this program, we should. Oh, here we go. Imported and not used buff.io. Hey, we took out, that's why it wasn't complaining before. I was expecting that to complain last time. Now we've given our buff.io over to our asker, we don't need it anymore. We still use funct, we don't use os. Do we use string convert? 52. Aha! Yes, now we're trying to do comparisons there. This should now be a comparison on yes. Is equal to higher, and here if res is equal to lower. That's interesting. Did we forget to actually ask? We did, didn't we? Oh dear, oh dear. Asker.go. What did we miss? Between the printf and the scanner, we forgot to actually do the scanning. Scanner.scan. I just wasn't paying attention when I copied. Oh dear. Scanner.scan. That should fix that problem. So yeah, just typo, fixing that. Say yes when you think of a number between 1 and 100. No. Error. No is not an acceptable answer. Say yes when you think of a number between 1 and 100. No. Yes. Is it 24? No. No is not an acceptable answer. Yes, lower or higher. So that's actually working quite well. Even though we got rid of the higher, lower, we can say higher. Is it 37? Lower. What if I say capital lower? Lower. No, it's not fine. Is it 28? Yes. Okay, he's thinking of a number. Okay, 50. No, higher. 75. Higher. 85. Lower. 80. I don't know why I'm still playing this. 83. 82. 81. We got it. So the full game played out there. He thought of a number. We thought of a number. He thought of a number. Everyone's won. During this lesson, we made a new package that we can refer to, and if we write another program, that can refer to that package in exactly the same way, using very simple. Not there. Using import mylib/asker. You can of course call that package whatever you want, and you don't necessarily have to put it in your lib. I've just created a folder of my lib so that my main packages can all see the libs in the same place, or have their own smaller libraries that don't all show up at the same top level. Now for a challenge. I want you in your Asker library to create a new function, a public one, so with a capital letter, and that function will ask for a number, but it will require that number to be within a range. So I'll give you the title for it. So if we do it, it'll be something like this: func ask range. And so again, we'll have a message, which will be a string. We'll have set. No, we're not going to have a set. Oh, we're going to have a low, and we'll have a high, and this will return an int, and you have to code all of the inside to make so that we can ask for a number that fits within this range, and it will only return a number when it's finally given a number in the appropriate range. So don't forget to like and subscribe, and I'll see you sometime in the near future. Bye for now.